such a POC, some of the challenges we faced, how we solved them. We'll show demos, not live unfortunately because of stuff. And demo gods were not really working with us this week, so we decided to record them. Anything I forgot?
No, let's go.
No, we have roughly 127 slides, so be prepared. Roughly, give or take. Could have been 37 as well. Right, so we're going to talk about a project called Project Yoda, which is the lab version of Project Einstein. And I've talked about Project Einstein earlier this week in a session with Frank Denneman, in which we showed how we built our own private AI foundation platform, fed it with our own information, and integrated it with our own business processes. But this is kind of the lab version on which we'll dive into. The project is kind of focused on a couple of layers. We're going to a little bit talk about the infrastructure layer using VCF. That's what Robert's going to talk about. And then when Robert's done, I'm going to dive into the private AI foundation part. Kind of the AI enterprise part. Yeah? Ready to go?
Let's do it.
The floor is yours, dude.
Thank you very much. Okay. So, AI, it probably involves containers. And that means it probably involves Kubernetes. So, for those of you unfamiliar with Kubernetes, it's really nothing more than a bunch of VMs. They just have a very specific role, and they're clustered together to do a thing. They create a Kubernetes cluster. Now, why do we need Kubernetes clusters? Because a lot of these AI frameworks work in containers. And to do AI at scale, or machine learning at scale, anything under the umbrella term AI, we need to scale horizontally. Containers are the best way to do all that kind of thing. So all these frameworks are all Kubernetes native now, right? Started with Docker, but now it's all Helm charts and stuff that you stick into Kubernetes. And the same goes for the NVIDIA stuff, right? So what Johan is going to show you is the NVIDIA stack specifically and how to get up real quick and get some very cool stuff working on GPUs. But it's all Kubernetes based, right? So it's a big part of it. You're going to need a Kubernetes cluster. Now, you're in luck because VCF and VMware vSphere Foundation both contains what is now called the supervisor, right? So it's no longer vSphere Tanzu.
No, we call that rebranding as a service.
Yeah, it's and this list, I've got another. So if you come to my other session at 3 o'clock, this list of what it's been called is actually that long. I've only done the last two. It's no more Tanzu, right? This is called supervisor now. And supervisor can do a whole bunch of things, but the most important thing it can do is it can create Kubernetes clusters very easily, and it create clusters that you need to do the AI thing on. Now, there is really just one little specific thing you need to customize for the GPU thing, and anyone who's done GPUs on VMs before will probably recognize this. We need to create a VM that enables GPU pass-through. Now, in Supervisor, this thing is spitting out whole Kubernetes clusters. It's building the VMs for us based on a template, and then it's applying a configuration, and we need to create a custom configuration, which they call a VM class, a custom class that enables the GPU pass-through, and then we can use that as the basis to build our Kubernetes cluster. So these VMs, they're called nodes in Kubernetes, and they have GPU pass-through enabled. That's really the only thing we need to do on the infrastructure level, except obviously ESX and the driver, but Johan will talk about that. Making a cluster is this easy, right? I copy-pasted this YAML from the docs this morning. I took out all the comments and anything that's already in there by default, and this is the simplest YAML you can have to make a basic cluster. 3 control plane nodes, the API for Kubernetes, 2 worker nodes, I can actually run the workloads. And here I'm referencing our little special customized class that does the GPU pass-through. But creating a cluster is it's just, you take that, you stick it in a file, you do that, and you have a cluster. So, ESX host with obviously GPU. You need the driver and probably a NVIDIA licensing server. We enable the supervisor. I'm not going to go into details about how that happens, but there's a wizard, basically. We create something called a vSphere namespace, which is a way to group the clusters we build. It's basically a resource pool with a bunch of extra stuff added on to make managing Kubernetes easier. We associate it with a network. This is where those VMs will go into, right, the nodes. We also need a load balancer. Now, there's a bunch of different load balancing options around Supervisor. I'm not going to go into that now, but you do need to do a load balancer thing before you continue. So that can be the AVI load balancer, or at this point still NSXT, but it's probably going to involve the AVI in some way. So you have to look into that, take care of that. And then once you have that, oh yeah, VIB network, because we're doing load balancing, right? So we have VIBs, virtual IPs. And then you can do this. You can say, make my cluster, and then we're going to install what we call operators. And I'm not going to go in detail, but that's his job. But Helm is just a tool to get stuff into Kubernetes. It's really not that more complicated than that. And an operator is a thing that does stuff inside Kubernetes dynamically. So the NVIDIA operator, you install the operator using Helm. It's very simple. It's just that line, basically, with a few more options tagged on. And the NVIDIA operator inside Kubernetes will actually bring up all the microservices that are needed by the NVIDIA framework to do GPU stuff. We're also going to install the NIM operator, which does a lot more stuff. But that also, so this ends up being a lot of different containers all running inside Kubernetes. And there's other stuff we can add on, like you can install Open Web UI in here. We'll get to why in a sec.
Yeah, we'll show that in a demo. Oh, could you go back? So there's one thing to mention. You see Harbor at the top right. So by show of hands, like who knows what would be your ideal container size? You build a container for a certain application. What will be the ideal size? Not thinking about AI at all. So an average microservices application. Couple hundred megs? Yeah? Who has heard about NIM? NVIDIA Inference Microservices. Right, so if you download like a decent model, Justin, what's a decent model, like a 30B model? It's big, eh? Right, so if you download that, you pull that, you run that, hypothetically you could easily end up with a Docker image that's 80 gigs in size. You don't want to store that in the default Harbor repository because it's unable to store it. So when deploying this, be aware that the Harbor registry needs to be increased in size and put it on storage. That makes sense as well.
Yeah, well, that's basically it because the next slide.
Oh, is this?
Is
awesome.
Yours.
Okay, let's talk about AI Enterprise. So Private AI Foundation is based on VCF and AI Enterprise on top of that. And we're going to dive into the AI Enterprise stuff right now. So on a very high level, you have the core services that you need to run a model or an inferencing application. So you have different types of models. Who has played around with Hugging Face so far? Oh, cool, couple of hands. So it's fairly easy to deploy a model. If you would use, for instance, a model from Meta, you have to register, and as soon as you've registered for that model, you can pull it, run it inside your environment. And if you do that in a custom way, it is, it's doable, but it can be complex. And this is why NVIDIA kind of invented the NVIDIA Inference Microservices, the NIMs. And a NIM is really, really, really awesome. Because what you basically do is you pull a single application to your infrastructure that contains everything you need to get started. It has the inference microservice. It has an optimized model. You can choose, and I'll show that in a bit. You can choose different models and fairly simple pull them. But it also has optimization for specific GPUs. It runs the vector database there as well. So you basically have a whole set of solutions, a whole set of microservices to really get you kickstarted. And I mentioned different models, how do you determine what model to use? And I'm going to give you kind of an idea of what the impact of a model is if you run that in your own environment. So I did a couple of experiments with different model sizes. Let's take a look at model Llama 3 8B first. So 8B means 8 billion parameters. One parameter is 2 bytes in size, so if you would run Llama 3B locally on your environment, it will take roughly 17 gigs of frame buffer just for the model, the base model to run. That's without any data being ingested in the model as well. So 17 gigs of frame buffer would definitely run on a single GPU, right? And I'm actually running this in a home lab with a 24 gig RTX 6000, run perfectly fine. Now, take another model, 7DB, which has 70 billion parameters. Requires 150 gigs of frame buffer. I have not found any NVIDIA GPUs in this case that have that amount of frame buffer on a single GPU, unless you would use something with NVLink, but that's a different situation. That's a challenge. And now, there's a Llama 3.1 405B model, which has 405 billion parameters, which requires roughly 900 gigs of frame buffer. Yeah, you're not going to put that on a single H100. So coming back to the question, like what model to choose, from a technical perspective, technical limitation perspective, this is definitely something you need to take into account. Choose a model that will run on your infrastructure, and we're talking about POCs, so don't exaggerate it by immediately going for a 405 model. And I'll explain a little bit from a model perspective, like what's the outcome, also what the difference is. And I'll show a really cool demo to show the impact. So some GPU considerations. Who has the money to buy a Blackwell SuperPod? Correct. Yeah? You can be honest. Right, so no one has. Well, no one, Meta. Who works at Meta? Well, so there are some hardware considerations. Bigger models logically mean bigger or more GPUs. Huge models require big clusters. More models require more infrastructure, and it adds up. So the really important thing with a POC, and you can completely compare it to a traditional workload you would run on a vSphere cluster that requires amount of RAM. RAM is the most important aspect of running such a model. As soon as you're gonna swap, performance will drop immediately. And sure, we heard a lot of things around memory tiering right now this week, which is really important, but this can kill you POC. So remember, if you're gonna do something like this, build an infrastructure to run that POC on, be aware of the limitations of your GPUs. So OEMs have different AI-focused options, and sizing and configuration in that regard is really important. One mistake we made in the past is, for instance, building on our own hardware or building a custom platform for a customer, and not assigning the right GPU to the right PCI lane. What happened was that multiple GPUs were assigned to a single lane, which was assigned to a single NUMA node, and as soon as we were extending the NUMA node to a different CPU, performance declined significantly. We saw the latency increase of the workload, so be aware that if you're going to go for a hardware option, the pre-built options that the OEMs deliver, like Dell or HPE, are definitely your way to go. Then from a GPU perspective, there are multiple ways, and Robert showed how to assign a GPU to a workload. There are different ways to assign those GPUs to the different workloads, if you want to. And you can take a picture of this table. There are a couple of things you need to take into account. When you look at the POC, it's really important to understand what your requirements of the workload are. Do I require a certain form of availability, and thus require maybe vMotion? Then you're kind of already limited in the ways you're going to assign the GPU to the workload. What to consider? Completely depends. So it depends on your requirements what to consider when it comes to those GPU configuration options. Now, deploying the GPU is also something that needs some lessons learned. And it's a huge list of stuff you need to do. Robert already mentioned you need to install the GPU drivers, you install a license server, you create a custom VM class, create the cluster, deploy the GPU operator, really important, otherwise you won't have any GPU capabilities within your application. And really important, test the operator and the runtime. One mistake we made is that, oh, well, or what I made in my lab, for instance, is that everything worked. I could run a Docker image locally on a machine, and I had GPU capabilities inside my application. But as soon as I started that Docker application on my cluster, the cluster wasn't aware of any GPU capabilities. So you definitely need to take those capabilities into account and ensure that it works. And validating that, there's a couple of simple applications you could use to validate it. The NGC platform, NVIDIA GPU Cloud, has several smart Docker-sized applications or Docker packaged applications you could use to test the capabilities. Then, deploying a NIM, and this is pure magic. It is seriously simple, and this is a short recorded demo. This is build.nvidia.com. I selected the Llama 3 8B instruct model, and what you can see here is a couple of really cool things. First of all, there are different options to use the model. In this case, for instance, the Docker command to pull it. Also, the way to reach out to the API endpoint, but also a Python script to directly talk to this hosted model. So I'm asking the 8B model, who is Johan van Amersfoort? And the answer it gives is that Johan van Amersfoort apparently is a famous racing driver from the Netherlands. I can assure you, he is not. I am commonly known for the, well, the challenge I had with the Dutch police for the last couple of years, and one of my colleagues, I borrowed his car quite recently. I got a fine of 400 euros, was not fun. Asking the same question to Llama 3.1405b gets a different answer. Johan van Amersfoort is a well-known IT expert and author who specialized in VMware and virtualization technologies. The result, the difference between the two models is that 405b has much more parameters and thus is more commonly trained on common knowledge, whereas 8b is trained on natural language but doesn't have any knowledge. So it assumes something based on the fact that the prompt I add, a simple prompt, does not contain enough information to create a really factual answer. So the bigger the model gets, the simpler the prompt can be to still get right information. But in some cases, prompting by itself is not enough, or makes things complicated. And I'll show you that in a demo in a bit. So, Robert mentioned Open Web UI. Really, really cool solution. So this is part of how we deploy those POCs. Open Web UI basically is simply deployed, again, using a Docker image, a Docker container that you can run on your environment. And what it does is a couple of things. First of all, it offers you a really simple RAG interface, an interface where you can upload your documentation. Second thing is that it is GPT-like, so it's very recognizable. And it kind of uses the same prompting as GPT does. And the third thing that's really cool, it offers the same API endpoint with the same API calls. So whatever you build from an automation perspective in ChatGPT, you can use that in Open Web UI as well. Let me show you a demo. So let's first dive into a little bit the configuration. So it works with workspaces. I assigned a model here. And I'm using, to configure the model, and you'll see that in a bit, the model endpoint. I uploaded a couple of documentations, the 2 books that I wrote. And if I now would ask a question, what is VDI? It'll answer the question based on the information it got from my 2 documents. I'm using a fairly small model, which I have no idea of VDI design guide, but based on these 2 documents, it kind of gives me the results. And in this case, he knows also that I'm an author based on these 2 books. Right, so let's talk about Yoda. I love Yoda. Who has no idea who Yoda is? Are you lying? Or no? Okay, good. I see there's a small animation issue in our slides. That's okay. We need that. That's the only thing you need to know right now. So what we built in terms of our POC is VCF with NVIDIA hardware based on Dell Technologies PowerEdge AI servers. On top of that, we run the VCF stack, including ARIA and VKS. Thanks for renaming that. Then on top of that, we run the NIMs. In this case, a NIM based on 8B, Laba 3 8B. And on top of that, we fed documentation into the model. Now, what you saw just in the demo is how we were able to use the Open Web UI interface to talk to, again, Open Web UI. When we ask a question, we get answers from the model. Now, what we wanted to do in terms of the POC is, because not everyone wants to use or consume such an interface, is do it differently. So we build a web service that integrates with Teams, and it uses a bot. So I can talk to a bot and I get the answer back in my Teams client. The way that traffic flows is that I have my end user that talks to Teams, Microsoft Teams, simple the Teams client, that talks to the bot, and there's a reason why it's called Yoda, that talks to the web service, that talks to the Open Web UI, that retrieves information from the NIM, and ends up at the web service. What I wanted to show in this demo is that the smaller the model, the less chance there is that the model knows who Yoda is and what language he speaks. So what we did to show that smaller models can still do their trick is that we integrated this with the Rapid API. That is a service that offers different types of APIs. One of them is the Yoda API. So simply, the question that I ask gets translated into Yodish, and the answer is traversed back to the end user. And it looks a bit like this. So, in my Teams client, I have me, Han Solo, and Master Yoda. And if I would now ask a question, who's Frank Denneman? You did the voice, right?
Frank Denneman, a virtualization expertise. Deep knowledge of VMware technologies he has.
Well, you get it. So the answer, what is Private AI Foundation? Oh, kind of same thing in Yodish. What's the number one question you would have to ask to Yoda? What's the number one question? Did Han shot first? We all want to know that, right? So Han shot first, apparently. Yoda knows it all. But this shows the simplicity of using a smaller model, using the right way of reaching out to APIs and getting the right information. And in this case, it saved our kind of our POC of using bigger models that have common knowledge of, in this case, Yodish. So some next steps. We can imagine that this kind of felt like drinking from a fire hose. We try to keep it as short as possible. We still have 1 minute and 35 seconds. But we can imagine you have questions, you'd like to know more. So this week, really cool, we launched our secure private AI service with NVIDIA, VMware, and Dell. And we can help customers build this for an enterprise-grade use case. So what we do end-to-end with those partners is build a VCF platform, get you kick-started on building that solution for you, but it doesn't end there, because honestly, building a POC, like showcasing an application, here's your chatbot, and now we'll leave the door. You saw how awesome the technology is. That is a challenge, because what happens if you are using Llama 3.1 8B right now, and next week a new model arises? So what we'll do as well is we'll help you, for instance, replace the model, help you to automate the process of feeding information into your vector database, but also offer platform engineering services to keep it secure, to keep it up to date, to automate the full process of building those applications for you. And I think this is just really cool. So if you want to know more, you can find more about the service as well as the stuff that we do on our website. We have 15 seconds, and I think we can still take on some questions, right? Are there any questions? Oh, there's a mic coming up.
What about the training models? Is it possible to train models?
Oh, it's definitely possible to train models, but the question is, why would you? And it's not a trick question. So the thing that Meta does really well is pre-train models for you. The environmental footprint of training a model is so huge that I'm probably not able to share it. Maybe it's in the demo of the 405B model. What you can see is with every single model you use, here, no, if you look at the model card tab, it shows how much power they consumed to train it. So, in case you have a really specific use case and would like to train the model yourself, it is perfectly capable you're capable of doing that, but you need a different approach to do it. Training a model is very complex. Justin Murray is here in the audience. He runs tech marketing for everything AI at VMware, and he's surely able to kind of tell you how complex it is to train a model. This is why NIM just offers you a pre-trained model already.
Yeah, but training.
But a good question, by the way.
But training a model doesn't imply teaching it new things. That's what this RAG is about, right?
Yeah.
Something is wrong.
Oh, the mic
yeah.
is dead.
We have a specific set of data which we are using for training models. Beside of that, we have changing model of data which we put in the RAG database. So in that case, we need to have some tool set for training models.
Is it structured or unstructured data?
For the structured.
Structured data.
Yes, for training is structured.
Definitely take meet up with Justin. He'll be able to talk more about that in detail. Cool. Any more questions? Awesome, then, well, enjoy the rest of the conference. Thanks for spending the time with us, and safe travels back if this is the last day.